So hey everyone, welcome back to my channel. This is Lakshya here. So today we're gonna start with our lead code question number 90, which says subsets part 2. So it's a medium level question. Let's see what it says. It says given an array nums that may contain duplicates, return all possible subsets means the power set. The solution set must not contain duplicate subsets. Return the solution in any order. So basically in this question we have to print all the subsets of a given array, but there must be not any duplicate subset, means there must be either 1 2 or 1 2 2 this. So how we can do this? Let's see. So for this, we have the example like this is our array. So how can we form subsets? So first subset will be always our empty set, then like this one will be our can be our set subset, then 1 2 can be, then 1 2 2 can be. Okay, now from 2 what we can form? We can form 2 and 2 2. Now from this 2 we can form 2, but we can see that this and this are duplicate. That's why we can't use this. We can only have one. That that's the only thing we have to keep in mind while approaching in this problem. Okay, let's talk about second example. It's also very simple. We have only one element in the set, so there are only two subsets like this. So this will be our resultant array. So how can we approach this problem? So this problem is also similar to our other recursion problems, the basic recursion tree approach. So let's see how we form our tree here. So let's suppose this is our array. So first of all, what we have to keep in mind, we have to always sort our array before starting our question, so that all the similar elements came to each side, means together. Let's suppose this array was something like this, then we have to convert it first like this only. Okay, so that we can check that if an element is similar to our previous, then we don't try to form another sets from it, because it will form the same sets that this will form. That's why. Okay, so let's start. This is our array. So at starting there will be nothing, a empty subset array. Then what we will do, we will simply return this. We will add this to our resultant array. That means we will add this, so we get an empty subset in a resultant vector like this. Okay, then we will start. Our index will be pointing to 0 at starting, so we can create a subset like this from the first index. Okay, okay, cool. At starting our I will be pointing here at the index. Okay, then we again push this to our answer. Whenever we form a subset, we push it to our answer set. Then again we can form another subset when our index, now our index is this at here. Okay, now we can also make another subset when our index is here, and in our here our index is here. Okay, now our index moves here. We can again create a subset. First we push it here like this. In this case our index is pointing to here. Okay, now we move our index further, then we will see that it have already exceeded our the length. Then we will simply return from here, means we can't form anything from here. Okay, then what we will do, we will pop this element and return. Then we will get this subset only. Then is there anything? Yes, we can approach the next here, because here our index is here, so, and our I is pointed to the same here. At this point we are at this index and our I is at same at this. Then we can, what we will do, we can move our I here. But if we move here, we can see that our i's is same, that our i's, that our nums of I is similar to our nums I minus 1, means its previous one. Then we will not do anything and we will simply return from here also. After this there will be not any cases, because we have already checked on all the cases. Then we will again return from here. Okay, now what we will do, we will simply pop, because we have to also keep in mind that we have to, whenever we push anything into our set, we must also pop it. So when we pop it, we will get again our empty string. Okay, like this. When we reach here, this point, our index was here. Okay, like here. But when we popped, so we will, or I will be here, and we have popped our value, which will be our index. That means now again we are at the empty set, and our eye is pointing to here too. Means we can start a new set too, and again push it. After pushing it, what we will do? Now our index is again at 2, and we can create new subsets. That means we can move further like this and again push it. After this we can't move any further, so that means we will return. At this case, index was here, so now our I was also here, means like this, our I was also here. So now our I also moves here, but we can see that I is similar to our previous one. That means we can't create any set, and we will return. Then again we returns from here. And when we return here, at this moment our index was here. You remember, our index was initially here, and it was our I moved here. First our I was also here, then we form this tree, then I moves here, then we form this tree. And when our I moves here, it checks that I is similar to its previous one. That means now we can't form any set from here. So these are the only sets which will be formed, and we will simply return this in our answer. Okay, so that's it. Let's write its pseudocode and understand more clearly about this. So this will be our main function, where we will be creating a resultant vector and a vector. Let's suppose name is as subsets. Here we will store a subset, and we will create a subset here, and we will store all the subsets here. Okay, then most important, first sort a list. Let's sort a list by array.begin till array.end. Okay, like this only. After this we call our function that we will be using. It will be create combination, let's suppose, and pass a value like array, and what else you have to pass? The index, that will be 0 initially, and a subset and a resultant. And at last we will return our result, which will be containing all our subsets. So let's see how our create combination function look like. First our array, then our index, that is initially 0, and a subset and a result. Okay, first step is we must push our subset to our resultant vector like this. This will push our empty set, which will always be in our subset, which will be in all the subset combination questions. Okay, that's why we will push it first. It will push our value like this in a resultant vector. Okay, then what we will do? Okay, then we will start a traversal. That means for I equals to index, we will put our I at a index until I is smaller than our array dot size. We will keep on traversing, and if, keep in mind, if I is greater than index, it means like this only. We are starting from here, but now I is here, so we can see that we have started from here, so that it doesn't matter. Okay, let's see here. Okay, let's take this example. Let's suppose we are here. Okay, that means we are trying to form some another set. So if we see that I is equals to index, that means I is here, I is not greater than index, I and index are pointing at the same location, then we will not fall under this condition. This will only occurs when the index was here. Suppose index was here and I is now moved here from here. That means I is pointing here and index was initially here. That means I will form another subsets copying this only. That's why at this case, when I is written this and array of I was equal to array of I minus 1. In this case only we will continue, means we will skip this iteration, and we will continue our loop by skipping this iteration. Okay, if not that case, we will simply push our value to a subset dot push back our value, which was array of I, and then we will call our function again, create combination, and what we will pass, same our array and our index plus 1, sorry, we will pass I plus 1. Okay, wherever our I is pointing, we will pass next value for the next set to create, and our subsets and our result. Okay, simple. And whenever it comes back, the backtrack function comes back, we will also perform pop operation so that it doesn't contain the same string now. Then only we will form a tray like this only. Here we called 1, then 1 2, 1 through 2. But if it comes back, then it will be 1 to 2, not 1 2, which it was earlier. So to make it earlier one, we must pop it. That's why we are popping here. That is subset dot pop back. That's it. This is our simple pseudocode which will help us form all strings. Sorry, all the subsets. Okay. So you must try this. You must try all the test cases and also perform a dry run to make it more clear in your head. Let's jump down the code. So here's your code which we have already discussed. First of all, create two vectors that will be a resultant and subset. Then sort the array. Then call your function. After calling your function, first of all push the value. Means push a subset which is in our subset to our resultant. Then start iteration from your index till your size of the array and skip the duplicates. And after that, after pushing and creating combination function calling, always pop. Okay, that's the important phenomena for the vector, that you always pop while backtracking so that you get your original string back. So that's it. This was your code. Now let's talk about the time complexity. Okay, so the time complexity will be big of n log n plus big of n into 2n. N log n is for sorting because we have used the sort function, that's why it takes n log n. And this is for our subset generation because we are generating to the power n subsets for n size of array. That's why this is a time complexity. And we can also write it as big of n into 2 to the power n. Why so? You must be thinking, because this value is far larger than our n log n. Okay, means it grows very much faster than n log n. That's why a time complexity can be also written as this. Let's talk the space complexity. Space complexity is big of n for the recursive stack that we are using. Recursive stack. Also big of n for the subset vector we are using, and also another big of 2 to the n into 2 to the power n for the resultant vector that we are using. Okay, because it's vector dot vector, that's why it takes this much. Again, the same space complexity can be reduced to, means can be written as big of n into 2 to the power n because it's far greater than this. That's why we can wrote it like this. So that's it. This is your time complexity. This is your space complexity. I hope it's clear. And here is your code. So that's it. That's for today. Make sure to try this question yourself also before copying it from here. So thanks for watching. See you till then. Bye bye.